In the first question, we have to find the unit vector that perpendicular for both vectors a plus b and a minus b. And the cross product of a plus b and a minus b gives the perpendicular vector of the both vectors. And the new vector w is equal to minus 2i plus 4j minus 2k. And we have to get the unit vector. For that, we have to divide by the magnitude of the new vector w. And the answer is here. And the second question, we have to find the area of triangle formed by vector u and v. We can get the area of parallelogram from the cross product of vector u and v, and we can multiply by half, and we can multiply by it half. In the question 2, we have to find the area of triangle formed by vector u and v. We can get the area of parallelogram from the cross product of vector u and v, and after we can multiply by it half, and we can get the triangle. So here is the cross product of vector u and v, that is equal to minus 2i minus 2j minus 3k, and the magnitude of the cross product is equal to root 17, and the area of triangle is a triangle formed by the vector u and v is equal to root 17 by 2. In the third question, we have to find the scalar projection C on D, and we have a formula for that. That formula is cross product of C and D divided by the magnitude of D. And the answer is here, that is 13.13 over root 29. And for the vector projection, we have a formula for that too, and the formula is the cross product of C and D divided by the magnitude of D squared, and we have to multiply by vector D. And the answer of that is minus 39 over 29 and 26 over 29 and 52 over 29. Thank you.
I will be doing the third question in the algebra assignment. The first question is to graph a logarithm function. The logarithm function is log 3 to the power x minus 1 plus 2. Because of the x minus 1, the graph is shifted 1 unit to the right, and because of the plus 2, the graph is shifted 2 units up. And for the domain for the graph to exist, x minus 1 has to be greater than 0. Therefore, there's a vertical asymptote at x equals 1, and the domain is from 1 to positive infinity. And because it's a logarithm function, range is from negative infinity to positive infinity. The second question is to translate is a translation of a sine graph, a sine function. So I'll be going through the y value differences and the x value differences accordingly. Y value first. First, I'll be stretching the graph by a scale factor of 4. Therefore, I'll be multiplying by 4, and then I'll be shifting it 3 units down, and therefore I'll be subtracting 3, and then reflecting across the x-axis. Therefore, multiplying by negative 1, and then difference in the x values. I'll be shifting the graph 3 units to the left. Therefore, I'll be adding 3 inside the bracket, leaving my final equation as minus 4 sine 2x plus 3 minus 1. And part C is to find some limits. So when x approaches 0 from the negative side, y approaches 0, and when x approaches 0 from the positive side, y approaches 2. Because these two are not equal, the limit at 0 does not exist. And when f equals 0, y equals 2, and the final one, when the graph approaches 4 from both sides, the limit is 4. Therefore, the limit of the graph is 4.
So in question 4, we have 4 matrices A, B, C, and D, and we have the equation AB is equal to C plus D. So first step is to multiply matrix A by matrix B. So in multiplication of matrix, we have to ensure that the number of columns in the first matrix should equal to the number of rows in the second matrix. So since this is verified, we can go on with the multiplication, and we will obtain a matrix with the order of 3 by 4 matrix. So to obtain, so next is C plus D. So this is simple addition. So to add or subtract matrices, we should ensure that the order is the same. So since mat C and mat D have the same order, we can add them. So it will give you a 3 by 4 matrix. So then we get two resultant matrices from A, B, and C plus D. So with the use of these resultant matrices, we can get a numerical value for the two equations in matrix C plus D. So with this numerical value for the two equations, we can solve the two equations simultaneously and obtain values for x and y. Okay, let it try. Okay. So next is part B. In part B, we have three equations with three unknowns. So we have to apply Cramer's rule for this. So to apply Cramer's rule, first we have to write the three equations in matrix format with the numerical values and the variables separately. So after writing that, to find x1, first we have to divide the determinant of x1 by the original determinant. So to get the determinant for x1, we have to substitute the first column in the matrix with the resultant matrix. So then you will and then divide that matrix by the original matrix. Then you will obtain the value for x1. This will be repeated in similar ways by replacing column 2 and 3 with the resultant matrix to obtain values for x2 and x3. So next up is part C. We have system of equations. So we have to find the values of lambda where the system of equations provide unique values. So to do that, first we have to note down the coefficient matrix of the given system. Then to find the determinant of this matrix, we have to use the cofactor expansion along the first row. So then now to calculate det A, we have to separately calculate the determinants of these submatrices we have obtained. After obtaining the answers separately for these submatrices, we should then substitute these answers back into the determinant formula. So once we substitute our answers back into the determinant formula, we can obtain a final equation for det A, which comes out as 7 minus 10 lambda. So now to ensure that the system has to have a unique value, we ensure that det A is not equal to 0. So that means 7 minus 10 lambda should not equal to 0. Therefore, when solving for lambda, lambda should not equal to 7 over 10. So that means this system of equations have a unique solution for all the lambda values, except when lambda is equal to 7 over 10.
So, question 5. Now, first of all, we have Newton's method for approximation. And to do this, we need to know the first derivative of the function, which is f dash x. Now, after dividing fx by f dash x, we can substitute values to this equation given over here. And to start this, we need to approximate x value, which is the starting x value, x1. Now, the question gave x1 as 1. So, after substituting 1 into the equation, we get a result of negative 2. Now, you cannot substitute negative 2 to get the third approximation since ln of minus 2 is invalid. You can't have a negative value inside the logarithm function. So, the third approximation is not real. Therefore, fx of 0, fx equals 0 has no real rules. So, next up, we have the second part where we have to use the trapezoidal rule to approximate the area under graph. And now to do this, we split the interval into evenly spaced parts, which in this case is by splitting into 5 parts. And we sum the area of the trapezium by drawing a trapezium for each of those parts. Now, once we do this by substituting the values into this equation over here. And the values after splitting it into the interval is 1 to 3. We have the values over here. Now, substituting that and adding them all up together, we get approximate area of 0.3683. Now, finally, we have the same thing, but instead of using adding the area of trapeziums, now in this case, we are using Simpson's rule, where you approximate the function to a hyperbolic graph, and then you add them together. Now, in here, the interval was 3 parts, because, there was a table of values, and after substituting them, we get the final summation to 148, and that is a word. Statement.
And I will be doing the question 6. First of all, we can't subtract lambda from A because lambda is a constant and A is a matrix. Therefore, we have to multiply lambda with an identity matrix. Then, for this equation to be true, A minus lambda I must be equal to 0 because x is a non-zero vector. After that, we need to calculate the determinant. Then we get 1 and minus 5 for the eigenvalues of lambda. To find the corresponding eigenvectors, these values must be substituted in place of lambda. When lambda equals to 1, we get minus 7 and 1 for the eigenvector. When lambda equals to minus 5, we get 1 and minus 5 for the eigenvectors. Question part B. For a sequence to be convergent, the limits has to exist and it has to be finite. When considering this equation, especially the denominator, when very large n values, the n is more dominant in the denominator. Therefore, n plus 10 to the power of 1 over 3 is, we can say that it is equal to n. When after that, in this equation, we can get when limits of n goes to infinity, square root of n is equal to infinity. Since this sequence is infinite, we can say that this series is divergent. The let's say that when limits of a goes to infinity, absolute value of a n plus 1 over a n is equal to L. And if L is less than 1, the series is absolutely convergent. L is more than 1, the series is divergent. If L is equal to 1, it is inconclusive. After calculating, we get 1 over 3 as absolute value. We get this. After that, checking the limits, when n gets to closer to the infinity, 3 over n 1 over n becomes 0. Therefore, we can say that when limits of n goes to infinity, the equation goes to 1 over 3, which is less than 1. This proves that the series is convergent. Thank you.